Hello and welcome to our video about types of chemical reactions. Quick question for you at the beginning. Why didn't Elsa go to the doctor when she got a sore throat? Is it because a cold never bothered her anyway? No, I know what you're saying. You're like, okay, Mr. Gordon, stop it already. Just let it go. You're welcome. Okay, all right, well, let's see. So we're talking about chemical reactions, and I thought I would show you a crazy chemical reaction. So watch this. In this video, notice this person is mixing some stuff together, put it in the jug. This is a totally real thing I could have done had I had access to a whole room full of chemical. What the heck? Did you see? You saw that, right? Right? See how it turns black instantly while it's being poured. And even 3 cups at once, we'll still see the same thing happen. This is actually an interesting multiple set of chemical reactions, and none of these are video tricks. This is actually what happens when you set up a certain set of chemical reactions. It's called the iodine clock, and I would have loved to do it in person, but now I'm going to show you the video of it. And now you've seen what happens there. Essentially is you get a bunch of iodine, and iodine is a very dark blue color, and the reaction happens so quickly it appears to suddenly just turn black. So, cool chemical reactions. Let's talk about types of chemical reactions. First thing is to note that all chemical reactions involve one of two things. So we are rearranging the places that atoms of different types are found in the process of chemical reactions. So all chemical reactions involve these two things, either breaking chemical bonds, so pulling atoms apart, or forming chemical bonds, joining them together. When we break them, we have to put energy in to break those bonds. And when we make bonds, we actually reduce energy, or I should say we release energy, because the atoms are getting into more stable situations, and so we're actually releasing energy. So there's always energy involved in chemical reactions because of what happens with these bonds breaking and forming. Remember, pause the video if you need extra time to take notes. So what this leads us to, and let me get the video out of the way a little bit here. What this leads to is two major classifications of chemical reactions that are important, and that's exothermic versus endothermic. Exothermic versus endothermic. So exo means outside, endo means inside. And so this is all about how much energy goes in which direction, from the reaction to its surroundings or from the surroundings to the reaction. So if the total amount of energy exchanged with the environment is more, then the reaction is exothermic. It gives off energy to its surroundings. And those are the reactions that we feel heat coming from. So a good example, of course, is burning wood. That's a chemical reaction, rearranging the bonds in the molecules inside of the wood, and as a result of that, we get a lot of heat. An opposite example would be one of these instant ice packs here. You might have seen these. You can just pull them out. They no refrigerator, no freezer necessary. You break the little bag inside, and it suddenly gets cold. And the reason is because it pulls a bunch of energy in from the surroundings. So to you, it feels cold because it's actually drawing energy away from you. All right, so after that, we're going to look at these 5 major categories, 5 major types that we can find all chemical reactions in. So these types. So the 5 are, and I'm going to go through each one of these, but I just wanted to list them so you know where we're going. We're going to talk about synthesis, decomposition, combustion, single replacement, and then double replacement. And then what you're going to want to pull out of this is the ability to tell from a chemical equation what kind of reaction you're looking at. All right, first is synthesis. What's a synthesis reaction? So synthesis means making something, creating something new. And that's when 2 or more substances combine to form a new compound. You got substance A, you got substance B. You stick them together, you get some new substance, of which in this case we're calling AB, right? A plus B equals yields AB. So you can tell because there's fewer things, fewer different substances on the right than there were on the left. There are fewer products than reactants because the reactants were squished together. Good example of that. Sodium and chlorine react to form sodium chloride. So in this little snippet from Nova's Hunting the Elements, you see they're cutting some actual pure sodium, and then that tank is chlorine gas. Stick them together, light them on fire, and this is what you get. You actually get, there's a reason there's popcorn hanging there. You get salt. So that's a synthesis reaction. Sodium plus chlorine are stuck together. They react together to form one compound. So there are two original substances and one afterwards, which is NaCl, or regular salt. So that's a synthesis reaction. Decomposition reactions. Decomposition, so just like decomposing, breaking down stuff, you might hear about that when it comes to soil and leaves and dirt. Decomposition, breaking down, so one compound breaks down into two or more smaller substances. So it's the exact opposite of synthesis. Substance AB breaks down into substance A, separate from substance B. AB becomes A and B. So again, easy to tell this one, there are more products, more different products than there are reactants. Again, pause the video if you need a little extra time to take notes or even just to think about what I've been saying. And here's a great example of that one. You might have heard this story. This woman won the Miss Virginia competition by doing a little science. Woo! So she did a well-known demonstration called elephant toothpaste, and which in that case just produced all of that crazy foam shooting up. And what is elephant toothpaste? Well, it is the decomposition of hydrogen peroxide. So H2O2, that's hydrogen peroxide, same stuff you might see in a first aid kit. And that's H2O2, and it breaks down into H2O, plain water, and oxygen, O2. And the way elephant toothpaste works is that they use some soap to trap the oxygen that comes out. And that soap keeps the oxygen from just going off into the air, causing all the soap foam to just go flying up, which creates that elephant toothpaste. That did win this woman Miss Virginia, so science can be pretty useful. Okay, combustion reactions. Here's another one, combustion. So combustion is exactly what you think it is. It's burning or exploding, right? And it happens when some substance reacts with oxygen. There has to be oxygen involved, O2 gas, and it has to end up at this release of energy in the form of light and heat. Obviously, these are exothermic reactions. And so combustion reactions kind of look like this. There's some compound with carbon involved. So these are generally organic compounds, the compounds of life. And that plus oxygen gives off, and the products are almost always carbon dioxide and water, plus some energy. So you burn anything, you're going to end up with these and then possibly some other things. So you burn some wood, very complicated compounds involved in that, add in some oxygen, and you release a bunch of carbon dioxide, a bunch of water, and then the leftover wood actually ends up as pure carbon, which is charcoal. But you also release lots and lots of energy. And so you can think of any example of things on fire or burning or exploding, but the example I'd really like to draw your attention to is something that you will see when you get into biology, and that's cellular respiration. So chances are you've already heard about the mighty mitochondria, the powerhouse of the cell, right? So this is a diagram of what the mitochondria look like. And what are the mitochondria doing? They're actually doing combustion reactions. So into the mitochondria goes glucose, which is a very simple sugar molecule that your body gets from breaking down bigger food molecules. And in comes some oxygen, which your body gets from the air, right? And then through some complicated processes, there's combustion in there. And as a result of the combustion, you get water. So that's why you have a lot of excess water in your body. You get carbon dioxide, which is the stuff you're breathing out. You're trying to reduce the concentration in your blood. And then most importantly for your body, you get energy. So it kind of looks like this, right? This is a glucose molecule. There's some oxygen, gives us carbon dioxide, water, and energy. And interestingly, of course, this energy, that's why you're hot, right? So this energy, you're getting the energy for your cells to do things, but because it's not perfect at transforming the energy, you get a lot of heat. And that's why you are 98 degrees, because this combustion process is constantly giving off heat. Okay, next kind is called single replacement. You have these replacement reactions, and it's basically somebody's taking somebody else's place. So in a single replacement reaction, you have a similar but more reactive element replacing another one in a compound. So in this case, let's consider this example. We've got substance A, which is, let's say, a pure element, and then substance BC, which is a compound. And in the course of the reaction, A takes the place of B. A takes the place of B because it's more reactive. You might remember at one point we said that as you go down the periodic table, things tend to become more reactive. So similar element, but with more reactive, takes the place of the other one, and then the one that got replaced ends up out by itself. And so a great example of this is something I've shown you before, which is what happens when you put sodium in water. So you've seen this wonderful YouTube genius throwing a pound of sodium into the water and into a pond, and it blows up like crazy. And that's actually a single replacement reaction. So you've got pure sodium plus water. The sodium takes the place of the hydrogen, resulting in NaOH. And then what's left over, just the hydrogen, which kind of got kicked out of the compound, is H2 gas. Hydrogen gas is very explosive. And so that's what happens, is that hydrogen gas gets lit by the heat from the reaction and explodes. And that's why you see such crazy stuff. Okay, and then our last kind is called a double replacement reaction. A double replacement reaction. So that's generally where we have ionic compounds, two of them, and the ions swap, right? They trade places. These generally occur when both of these compounds are dissolved in water, and you can identify them when one of the products comes out of the solution as a solid or a gas. So it might look like this. You've got a compound that's AB, right, element A and element B, and another compound that's element C and element D, CD, right there, right? And so when they swap places, you end up with A joining up with C and B joining up with D, and so you have these two totally different compounds afterwards. Again, pause the video if you need extra time to write down. Here's an example of that. Let me see if I can get myself out of the way here. An example of that is this cool reaction I believe I've shown you before, which creates this beautiful yellow solid in solution. So you pour these two clear liquids together, and what you're doing is you're combining a potassium iodide, Ki right there, with lead nitrate. That's this one right here. And you can see I colored things so you can see the swapping. The green ones come together, the blue ones come together, and you're left with potassium nitrate. And then it's the lead iodide, sorry, not the lead nitrate. The lead iodide is the precipitate. So that's that yellow stuff that comes out. That's really cool. Okay, a couple of quick examples of the kinds of problems you might have to do with this. What type of reaction is this, right? We've got iron plus copper chloride. That's copper 2 chloride if you're remembering your bonds. And when they react, they become iron 2 chloride and plain old copper by itself. What type of reaction is this? So pause for a moment, see if you can do this one in your notebook. Okay, and so hopefully what you saw was that what really happened was just that the iron and the copper switched places, right? The iron became part of the compound, the copper left off by itself. And so that tells us there is a single replacement, right? One thing is replacing another. That should be a single replacement reaction. Next one, what type of reaction is this? So we've got C8H10 plus O2, and that gives us CO2 plus H2O plus heat. And so that's that common pattern that I showed you already. You've got a compound involving carbon, and you mix it with some oxygen, and you get these three things in the end. Take a moment, pause, and try this in your notebooks. Okay, hopefully you identified that as a combustion reaction. So carbon compound plus oxygen gives off carbon dioxide, water, and heat. And this C8H10, you might think of it as being octocarbon decahydride. It's better known as butane, right? So this is basically the I just lit a cigarette lighter reaction right here, and that's a combustion reaction. Okay, so that's it for this video. I hope you enjoyed. As always, make sure you go back, review anything you might need to, and make sure your notes look good for what you're going to need to do. See you in the next video.